Okay, welcome back. Today we're going to continue on with our section 7.3 and 7.4. Primarily, this will be the first lecture for section 7.4. And you can see there the name of that section, determining chemical formulas. We're going to do two types of problems here: empirical formula problems and what we call molecular formula problems. And really, the empirical formula problems are kind of the opposite of percent composition. You either start with a percentage or a gram amount of each of the individual elements in that compound, and your final answer is actually the compound itself. So you're going to be writing a formula for your final answer. So you can see there it says when a new substance is synthesized or discovered, it's analyzed quantitatively. Remember, that's with numeric data to reveal its percent composition. From this data, the empirical formula can be determined. So this empirical formula that has the symbols for the elements with subscripts showing the smallest whole number ratio. So you're just going to be writing a compound. And you can also be naming these as well. You can name them perhaps kind of looking back on what we did in section 7.1. Okay, so this next slide has your guidelines for performing these problems and getting the correct answers. So the first thing you have to do there, it says convert the percent composition to mass composition. Sometimes you're given mass composition, it'll give you gram amounts of each of your substances. If you are giving the gram amounts, you just start there from those gram amounts and go on to step 2. But if you're given percentages, this is very simple. We're going to assume that we have a 100-gram sample. So our percentages will be our gram amount. So if it says you have 10% of this substance, we'll write that as 10 grams and so on. Okay. Our next step, step 2, is to convert those mass amounts to moles. Now, this is actually going back to what we did in chapter 3. It'll just be an element, so you just look up that mass from the periodic table and you go from grams to moles. So in this case, you'll be dividing by the mass from the periodic table. Then you have mole amounts of each of your different elements. Okay. Then step 3, it says divide the mole amount by the smallest number of moles. So whichever one is the smallest, you're going to divide all of them by that particular one. Okay, so one of them will always end up being 1 because you'll be dividing it by itself. Okay, and then we're going to round to a whole number. If it's very close, 1.999, we're going to round that to a 2. We're looking for whole numbers. The only time that it may not be a whole number, and you can see down here, is if it ends in a 0.5. Like if you get 2.5, then we're going to multiply everything by 2 to turn that 0.5 into a whole number. Remember, in a chemical compound, you cannot have decimals. Okay, so you always have whole numbers in those. So the best way here is to just really get started with one of these samples. Okay, and here's our first one. A compound is analyzed and found to be or contain 36.70% potassium, 33.27% chlorine, and 30.03% oxygen. What's the empirical formula of the compound? Okay, so the first step, we're just going to write it like that. Okay, and that's going to be going from percent to grams. So remember, I said we assume we have a 100-gram sample. So this is just going to be 36.70 grams of potassium. So that's going to be K. Okay. Then we're also going to have 33.27 grams of Cl. And we're also going to have 30.03 grams of oxygen. Okay, so we're going to write all those like that. Okay, so here's our amounts. So step 2, change these to mole amounts. So with each one of these, you're going to have a small little mole problem that you have to do. Okay, to convert each of these to moles. The good thing is it's not a compound. It's just an element, so you just have to look it up off the periodic table. So in 1 mole of K, you have 39.10 grams. I'm going to put that down here. 39.10 grams. Okay. That's a 9, 39. There we go. That looks better. So again, grams on the bottom, so they cancel. Okay, for chlorine, that's going to be 35.45 grams. Okay, in a mole, in 1 mole. And lastly, hopefully you're getting to know oxygen is 16 grams in 1 mole. Okay, so your gram amounts cancel. So we're going to get little mole amounts for each one of these. Let me pull these up on the calculator. 36.70 divided by 39.10. And that gives me like 0.9386. 0.9386. And that's going to be mole of K. Okay, our next one, 33.27 divided by 35.45, 0.9385. A lot of times you'll see these be very close to the same thing because it means their ratios in the compound are exactly the same. Moles of Cl. And lastly, for O, 30.03 divided by 16, you get 1.877. Mole of O. Okay, so that's step 2. So you change it to moles. Now, step 3, divide by the smallest mole amount. So out of these 3 or 2 or 4, however many you're given, find the smallest mole amount and divide everything by that. So the smallest mole amount, barely, but it is 0.9385. So we're going to go 0.9385. Well, that was a bad 9385. But that's going to be 1 because you're dividing it by itself. Okay, 0.9385. Now, I'm not even going to pull this one up on my calculator. It's so close. Even though it's going to end up being like 1.000 something, it's a 1. Okay, the ratios are very similar. And then lastly, 0.9385. Okay, when you do that, I'm just going to pull it up to see 1.877 divided by 0.9385. You get exactly 2. That comes out to be exactly 2. Pretty wild. Anyway, so that's 2. Okay, so these are our whole number ratios of these elements in the compound. So the last thing we have to do in the answer is just write the compound. It's going to be 1K, and it'll always, in our problems, will always be put in the correct order. 1 Cl and 2 O's. KClO2, potassium chlorite. Okay, KClO2. So that is your final answer, KClO2. After all that math, you come down and you have the correct answers being that. Okay, so percent to grams, grams to moles, divide by the smallest, get a whole number. Okay, let's take a look at this next one. Quantitative analysis shows that a compound contains 32.38% sodium, 22.65% sulfur, and 44.97% oxygen. So again, we're just going to write these out. 32.38. Okay, that's going to be grams of Na. Remember, sodium's Na. Okay, next one, 22.65 grams of sulfur. Okay. And 4.97 grams of oxygen. Okay, so there's your three values, percent to grams. Now we just have to convert these all to moles. Okay, so sodium is 22.99. That's going to go on the bottom. Okay, there we go. All right, 22.9. That's a 9. There we go. 9. That looks a little better. Sulfur, 32.07. Okay. And oxygen is 16. So I'm going to shorten this up a little bit. You should write 1 mole on the top. You should write that each of those you have gram amounts. Okay, but I'm going to leave you there. 32.38 divided by 22.99, that's 1.408. Now, I wouldn't round too much. Some people round too much and then you don't get the right, you get off a little bit. Okay, and that is moles of Na. Okay, then 22.65 divided by 32.07 is 0.7063. 0.7063, that's a 0 there. Okay, that's moles of S. And then 44.97 divided by 16 is 2.811. Okay, moles of O. Okay, so you've changed your percent to grams, your grams to moles. Now divide by the smallest. Okay, don't change it to whole numbers yet. Some people want to round here. So 0.7063. Okay, that's going to be a 1. 0.7063. That's going to be a 2. You can do the math on your calculator, but it's being real close to 2. And then 0.7063. That's going to be a 4. Okay, so there's your individual ratios. So just write it out. Na2 SO4. So that is sodium sulfate. Sodium sulfate is your final answer. Okay. All right, one last one to wrap this up. Now, for this one, you can see we're given gram amounts. So you don't have to do anything else, but write those. There's not much to do when you're given percentage either. You just write it as grams. But, so we have 29.84 grams of sodium and 67.49 grams of chromium. Put that down there. Grams of Cr. Okay, and then 72.67. Let me put that point right there. There we go. 67 grams of oxygen. So we're going to convert these to moles by dividing by the mass from the periodic table. Oxygen, again, 16. Sodium, we just did that one, 22.99. And chromium, 52.00. So that's 52 exactly. 52.00. All right, what are these going to equal? So we're going to go through and determine our mole amounts. Again, I shortcut a little bit there, left a couple things out, but 29.84 divided by 22.99, 1.298. 1.298. Okay, that's moles Na. All right, 67.49 divided by 52 is 1.298. Same thing, 1.298 mole of Cr. And lastly, 72.67 divided by 16, 4.542. 4.542. Whoop, 2. That's going to be mole of O. Okay, so we have 1.298. Oops, 1.298 and 1.298. Okay, so hopefully you know 1.298 for these two, 1 and 1. Let's see what this one is. 4.5 divided by 1.298. I say that because you get 3.499, okay, which is really 3.5. You see this every once in a while. I want to do one as an example. So we can't write the formula 1, 1, and 3.5. We need whole numbers. So to make this a whole number, we have to multiply this by 2. If we multiply this by 2, we have to multiply this one by 2, and we have to multiply this one by 2. Okay, so then we get a set of whole numbers, because our mole ratios didn't come out to be exactly whole numbers. We have 2, 2, and 7. Okay, because we can't use 3.5. So when we go back to write these, Na2, okay, Cr2O7. That might look familiar to you, that Cr2O7 is dichromate. So this is actually sodium dichromate, because we couldn't write NaCrO 3.5. And even if you change that to a 4, if you rounded that up, that's not the sodium's a +1. CrO4, which is chromate, is a -2, so it should be Na2CrO4 if that happened to be the compound, which it's not. So this is the compound that it is here. Okay, so for your assignment, I think you have 5 of these to do. For tonight, make sure you go back over here if you need to and check out what we did. And if you have any questions, let me know.